Hello guys, welcome to another video. In this video, we'll solve questions related to seepage analysis. Actually, if you see, from 2018, GATE has stopped to ask questions from seepage analysis. But we will solve the questions from 2014 to 2018. So if you see the given question, they've given that the coefficient of permeability, which is equal to 3.8 into 10 to the power minus 6. And they've asked us to find out the quantity of flow under the dam. Okay, so we'll write down the given data. So given K equal to 3.8 into 10 to the power minus 6 meter per second. And if you see the diagram, see this is one flow channel, this is another flow channel, and this one is third flow channel. So NF number of flow channels is 3, and number of equipotential drops, which is, so this is one equipotential drop, two equipotential drop, 3, 4, 5, 6, 7, 8, 9, 10. So total number of equipotential drops is 10. Solution. The equation of discharge from seepage analysis is given by Q equal to KH NF by ND. So H is nothing but height of water table above ground level, that is 6.3. So Q is equal to K, 3.8 into 10 to the power minus 6 into 6.3 into 3 by 10, which gives you 7.182 into 10 to the power minus 6 meter cube per second. If you convert this into centimeter cube per second, then it will be 7.182 into 10 to the power minus 6 into 10 to the power minus 6 centimeter cube per second, which will be Q equal to 7.182 centimeter cube per second, since they have asked us to find out in the centimeter cube per second. In this question, they have given that water is flowing at a hot, steady rate through a homogeneous and saturated soil horizontal strip of 10-meter length. Then we'll write on the given data. So the total depth of soil strip is 10-meter length, and they have also told that the strip is subjected to a constant water head of 5 meter at the beginning and 1 meter at the end. So HA will be 5 meter and HB will be 1 meter. And they asked us to find out the value of H at the middle of strip, that is at Z equal to 5 meter, H equal to what? Okay. Solution. They have given the equation d square H by dx square equal to 0. If we integrate it once, that is d square H by dx square is equal to 0, which will gives you dH by dx equal to C1. That is constant. So again we will integrate dH by dx is equal to C1, which gives us H is equal to C1x plus C2. Now at x equal to 0, where that is beginning of the soil strip, so head will be equal to 5 meters, that is HA will be equal to H. Okay, so which gives you 5 equal to C2, and at x equal to 10 meter and HB, that is 1 meter, so here H is equal to 1 meter, so 1 equal to C1 into 10 plus C2, which is 5. So C1 will be equal to minus 4 by 10 or minus 2 by 5. Therefore, h equal to minus 2 by 5x plus 5. So they've asked us to find out the value of h at middle of this oil strip, that is at x is equal to 5. So h equal to minus 2 by 5 into 5 plus 5. Therefore, head of water at the middle of strip will be equal to 3 meter. In this question, they have asked us to find out the relation between discharge velocity and seepage velocity. So if you see that the equation of seepage velocity is equal to V by N, where V is the discharge velocity and Vs is seepage velocity. So N equal to porosity, where it is N will be equal to Vv by V, volume of voids by total volume, and porosity is always lesser than 1, which gives Vv by V is lesser than 1, which means V Vv is lesser than V, then Vs is equal to, then Vs is always greater than V. So seepage velocity is always with seepage velocity can never be smaller than discharge velocity is the right answer. Let us write down the given details from this question. Given. So they have given that flow net comprising of 10 equipotential drops and 20 flow channels. Also they have given the coefficient of permeability and head loss. They asked us to find out the rate of seepage, which in centimeter cube per second through the earthen dam. So equipotential drops ND equal to 10, flow channels NF equal to 20. The coefficient of permeability K will be equal to 3 mm per minute, which is 3 into 10 to the power minus 3 meter per minute, and if you solve, it will be equal to 3 into 10 to the power minus 3 by 60 meter per second. Okay. Solution. Also they have given the head loss h equal to 5 meter. So we know that q equal to kh nf by nd, which is 3 into 10 to the power minus 3 by 60 into head loss, it is 5 into nf by nd, which is 20 by 10 meter cube per second per meter length of dam, which gives so 1 by 2, which is nothing but 0.5 into 10 to the power minus 3 meter cube per second per meter length of dam. So if you change meter cube to centimeter, where you will get 0.5 into 10 to the power minus 3 into 10 to the power minus 6 meter cube per second per meter length of dam, where it will be 500 centimeter cube per second per meter length of dam. In this question, we know that the relationship of quicksand condition will be equal to IC is equal to G minus 1 by 1 plus E, where 1 by 1 plus E equal to 1 minus N. Nothing but the relationship between porosity and void ratio. Okay. So therefore, IC will be equal to G minus 1 into 1 minus N. And they have given the porosity of 30 percentage, which is nothing but IC is equal to G minus 1 into 1 minus 0.3. G minus 1 into 0.7. So IC by 0.7 equal to G minus 1, which gives G equal to IC by 0.7 plus 1. So in turn we get G is equal to 1.43 IC plus 1. And if you see the options, option C is the right answer. In this question, they have given that the embankment depth, that is 12 meter, and coefficient of permeability of soil is 10 to the power 6 minus 6 per meter per second. Sorry. So we'll write on the given data where K equal to 10 to the power minus 6 meter per second, and difference between the water levels, which is head loss, H is equal to 4 meter. The flow net is constructed with 5 number of flow lines and 11 number of equipotential lines. So therefore, flow channels will be equal to number of flow lines minus 1. So number of flow lines minus 1 will be equal to 5 minus 1, that is 4. And ND, equipotential drop, will be equal to number of equipotential lines minus 1, that is 11 minus 1, which will be equal to 10. They asked us to find out the quantity of seepage in centimeter per second. So Q equal to KH NF by ND. That is 10 power minus 6 into H4 into NF. NF will be 4 by 10, which gives 16 into 10 to the power minus 7 meter cube per second per meter. Q equal to 16 into 10 to the power minus 7 into 10 power 6 centimeter cube per second per meter. Therefore, Q equal to 1.6 centimeter cube per second per meter length of dam. In this question, let us write down the given data. They have given that number of equipotential drops ND is equal to 24, number of flow channels is 7, difference between upstream and downstream, that is head loss is equal to 6 meter, and length of flow line adjacent to the dam exit, that is L exit, is equal to 1 meter, and they have given the specific gravity as 2.7 Also void ratio is 0.7. And now they are asking us to find out the factor of safety against piping. Solution. Factor of safety against piping will be given by critical hydraulic gradient by exit hydraulic gradient. And we know that the equation of critical hydraulic gradient will be equal to G minus 1 by 1 plus E, which is 2.7 minus 1 by 1 plus 0.7. 1.7 by 1.7 will be equal to 1. And the equation of exit hydraulic gradient will be equal to del H by L, where del H is equal to H divided by ND by L exit. And we know that head loss is equal to 6 meter divided by 24 divided by 1, which will be equal to 1 by 4. So if you substitute these two in the factor of safety equation, FOS will be equal to critical gradient 1 divided by 1 by 4, whereas factor of safety equal to 4. And option D is the right answer.